In this section, we're going to find the expected value, variance, and standard deviation of a discrete probability distribution using Excel or Google spreadsheets. Again, remember to pause often, complete these problems with me, have a spreadsheet ready, and pause the video often. So when we talk about expected value, that's the same as finding the population mean, and we use the symbol mu. For the population mean and for the expected value, we just say E of x. And how we actually calculate the expected value is we're going to take each value and multiply it by its probability and add those all up. To find the variance, we are going to use this formula here. So we'll take each value, subtract the mean, square it, and multiply it by its probability. And to find the standard deviation, we'll square root that answer. And the great thing is we're going to use Excel. You can also use Google Sheets. That's what I usually use. And we will do these examples and U-tries with Excel. So basically we'll put the value, so this is kind of our traditional probability distribution from the previous one. We'll type these values in, and then we will multiply here. So this is the formula. We'll multiply these two together, and then we'll sum these here. So this is just telling you what's typed in, and this sum here becomes our mean. We'll actually use that value in this here to calculate the rest. So I think it's easiest if I do this problem with you. So it wants the expected value, variance, and standard deviation. So here I'm typing into my sheet. So here I'm going to put the value x, p of x. This is going to be x times p of x, and the sum of that is going to give us our mean. And then here we're going to do x minus mu squared times the probability of x. And I just kind of put those in there to help me. So our x values are negative 23, negative 17, negative 9, and negative 3. And our probabilities associated 0.5, 0.25, 0.15, 0.1. So here we'll click enter, equals, and then this times this. And if you have Google spreadsheets, it might actually like autofill this, and you can just drag it down and that'll give you those as well. So then here we're going to do the sum of these columns here, and that is actually going to give us our expected value. So our expected value, we can put equal. So now to find the variance, we are going to do parenthesis here. Our x, is this column here, minus our mu. You could do minus negative 17.4 or just plus because subtract a minus, squared. And then we're going to multiply by our p of x. Just be careful that you're using the correct column. And then you're just going to drag that down. And then we're going to find the sum. And then that is our variance. So our variance is this value here. And our standard deviation then is equal to the square root of this number. And so it would be 6.86. So in this example here, we'll do it again. And I've kind of already set up the columns here. So Brad Williams, owner of a car dealership, decides to construct an incentive compensation program. So calculate the expected value of the annual bonus. So our x values here are in thousands. So we've got 10, 6,000, 3,000, and 0, and the probabilities going on in. And again, you can do this in Google Sheets or Excel. And then we're going to calculate this times this, and we can just drag it on down. And then the sum of these here, you got to put an equal if you want it to work. And there we go. And that is our expected value. So our expected value is this, but in thousands, right, it would be 4,200. Now, that's the expected value of the bonus. Calculate the variance and standard deviation. So we'll go over here. This is equal to the x value minus, and we just want to type in the mu, squared times our p of x. I'm going to just drag that sucker down, sum that up. And so our variance is this amount, and our standard deviation is the square root, of that amount. So what is the total amount that Brad can expect to pay in bonuses if he has 25 employees? So we'll use the expected value here. So we expect him to have this amount and 25 employees. So it looks like it's going to be about $105,000 in annual bonuses. We'll do a couple more together and then you'll practice on your own. So a marketing firm is considering making up to 3 new hires. Given its specific needs, the management feels that there is a 60% chance of hiring at least 2 candidates. There is only a 5% chance that it will not make any hires and a 10% chance that it will make all 3 hires. What is the probability that the firm will make at least 1 hire? So let's just build our probability distribution here. So we have 0 hires, 1 hires, 2 hires, 3 hires. So what are the probabilities? At least 2 hires, we're going to pause on that for a sec. Only 5% chance no hires, so this would be 0.05. 10% that it will make all 3. And then let's think about this for a second. 60% chance of at least 2 candidates. At least 2 would be 2 or 3. So the sum, 2 or 3, so the sum of these 2 is 60%, which means this has to be 0.5. Now remember that the sum of all these needs to be 1. So this would be 0.65. So this missing 1 here is going to be 0.35. Now, what is the probability that the firm will make at least 1 hire? So at least 1 hire, and we'll just kind of go over here, at least 1 hire, is going to be the sum of, well, we can do it piece by piece. At least 1 hire would be 1 hire plus 2 hires plus 3 hires. So that is the probability of at least 1 hire. The other way to look at that is there's only a 5% chance that it will not make any, so it'd be 1 minus that. Find the expected value in the standard deviation. Move that over here because, so the expected value, right, we need x times p of x, and here we need x minus mu squared times p of x, oops, lowercase x. All right, so we just kind of go through here, do this times that, and sum those up. And this here is our expected value. So the expected value is 1.65 hires. So here, we're going to do x minus 1.65 squared times the probability, drag it on down. And the sum of this is going to give us our variance. So our variance is equal to this, and our standard deviation is equal to the square root of that. All right. And finally, one more example. Organizers of an outdoor summer concert are concerned about weather conditions. They will make a profit of $12,000 on a clear day, $8,000 on a cloudy day, and a loss of $3,000 if it rains. It is predicted to have a 75% chance of rain on that day. Calculate the expected profit from the concert if the likelihood is 20% chance of sunny and 5% chance of cloudy. So we've got here like clear. The x, I'm just adding one more because it's 1, 2, 3, because it's a little bit tricky here. Cloudy, maybe it's helpful to kind of have some words here. 8,000. And then rain is 3,000. And the probability of each of these, so clear day would be the same as sunny. So that is a 20% chance. Cloudy, 5% chance. And rain, 75.75. So the expected value, the expected profit here is going to be, we're going to multiply those two, drag it down. So the sum of these 3, excuse me, this is a loss of 3,000. There we go. So that's going to change all of our numbers when you make a little mistake there. There we go. So now the expected profit for this here is $550. Give this one a try. Give both of these a try. Press play when you're ready to see the solutions. And that concludes this section.